In 1969, inside a quiet laboratory at UCLA, a machine tried to speak to another machine hundreds of miles away. According to UCLA Historical Archives, the first message sent over ARPANET was supposed to be the word login. It only managed to send hello before the system crashed. 2 letters. That was the birth cry of the internet. No one in that room imagined that those 2 characters would eventually connect billions of people, reshape economies, and redefine power itself. 20 years later, in 1989, a British scientist named Tim Berners-Lee proposed something radical at CERN. According to CERN's official archives, he designed a system that would allow documents to link to one another across a global network. It was called the World Wide Web. It sounded harmless. Just a way for researchers to share information. But what he unknowingly built was the nervous system of a new digital civilization. In 1995, the internet was still small, almost fragile. According to Internet World Stats, only about 16 million people were online worldwide. That was less than 1% of the global population at the time. It felt experimental, almost optional. Yet venture capital poured in. Engineers worked through the night. A quiet belief spread among technologists. Whoever controlled this network would shape the future of humanity. By the year 2000, the dot-com bubble had swelled to nearly $5 trillion in market value, according to historical Nasdaq data. Companies with no profit, sometimes no product, were valued in the billions. The world wasn't investing in websites. It was investing in dominance. When the bubble burst, trillions evaporated overnight. But the infrastructure remained. And infrastructure is power. Then came 2007. According to Apple's financial reports and industry adoption studies, the smartphone accelerated internet usage beyond anything previously recorded. The network was no longer something you visited. It lived in your pocket. It tracked your location. It captured your attention. According to multiple digital behavior studies, average daily screen time began climbing into hours. The internet was no longer a tool. It was an environment. By 2023, more than 5 billion people were online, according to the International Telecommunication Union. Over 60% of humanity was connected to the same digital bloodstream. Every message, every purchase, every search created data. According to global data estimates from research firms like IDC, the world now generates zettabytes of data annually. The internet did not just connect people. It began recording them. But even at its peak, the internet had a limitation. It could store information. It could transmit information. But it could not understand it. Humans still had to search, interpret, decide. According to behavioral research on search engines, billions of queries are typed daily because people still must ask the right questions. The internet was powerful, but it was passive. It waited for us. Then, quietly, another field had been evolving in the shadows since 1956, when the term artificial intelligence was coined at the Dartmouth Conference, according to academic historical records. For decades, AI was mostly theory and narrow experiments. But according to the Stanford AI Index report, the last decade marked unprecedented acceleration in funding, research publications, and computational power. Private investment in AI has surged dramatically. According to the Stanford AI Index and Global Venture reports, annual AI investment has reached tens of billions of dollars in recent years. Corporations are not investing because it is interesting. They are investing because it is strategic. Because AI does not just store information. It extracts patterns. It predicts behavior. It makes decisions at scale. The internet connected the world. Artificial intelligence is beginning to interpret the world. According to research from McKinsey Global Institute, up to 60 to 70% of work activities could be partially automated using current technologies. This is no longer about faster websites. This is about systems that think. And if you want to understand where this leads next, subscribe now, because what comes after connection is control. For decades, artificial intelligence remained confined to research labs and academic journals. According to historical computing records, Early AI systems in the 1970s and 1980s struggled with limited processing power and scarce data. Progress was slow, almost disappointing. Many declared AI overhyped. Funding dried up during what researchers later called AI winters. But beneath the surface, computational power kept doubling, following trends described by Moore's law. Silence was not failure. In the 2010s, something changed. According to the Stanford AI Index report, the amount of data generated globally began increasing at exponential rates. Cloud computing expanded. Graphics processing units became powerful enough to train deep neural networks. Research publications in AI multiplied several times over within a decade. The field did not just grow. It accelerated. And acceleration in technology often precedes disruption. Then came machine learning breakthroughs. According to peer-reviewed research in journals like Nature and Science, deep learning systems began outperforming humans in specific tasks such as image recognition and strategic games. In 2016, an AI system defeated a world champion in the game of Go, a game once believed too complex for machines. It was not just a win in a board game. It was a signal that machines could handle complexity once thought uniquely human. Investment followed capability. According to global venture capital analyses cited in the Stanford AI Index, private AI investment reached record-breaking levels in recent years, totaling tens of billions annually. Governments also increased funding. According to OECD policy tracking, multiple nations launched national AI strategies. This was no longer a research experiment. It was geopolitical competition. The race was not about building apps. It was about building intelligence infrastructure. In 2022, generative AI entered the public consciousness at unprecedented speed. According to platform usage statistics released by major AI providers, millions of users adopted conversational AI systems within weeks of launch. Research comparing adoption curves showed that generative AI tools reached mass users faster than early social media platforms did. The internet had taken years to spread. AI spread in months. According to McKinsey Global Institute research, up to 60 to 70% of current work activities could be partially automated using technologies that already exist. That statistic does not mean jobs disappear overnight. It means tasks shift. Decision-making shifts. Power shifts. When intelligence becomes scalable, efficiency becomes mandatory. Companies do not adopt AI because it is fashionable. They adopt it because competitors will. AI is already embedded in systems most people never see. According to industry hiring surveys, a majority of large enterprises use automated screening systems to filter job applications before a human ever reviews them. Algorithms decide which resumes rise and which disappear. The internet once displayed information neutrally. AI now ranks, prioritizes, and silently judges. Recommendation systems powered by AI shape digital reality. According to engineering disclosures from major technology platforms, machine learning models determine what billions of users see each day. Content is filtered, ordered, amplified, or buried. The internet used to be a library. AI turned it into a curated feed. And whoever controls the curation controls perception. Global data creation continues to expand at staggering levels. According to data industry research firms like IDC, the world now generates zettabytes of data annually. Humans cannot manually process that scale. Artificial intelligence can. The internet created oceans of information. AI builds fleets to navigate them. When navigation becomes automated, influence becomes scalable. The internet connected humanity. Artificial intelligence is beginning to interpret humanity. According to workforce trend research and enterprise adoption studies, companies integrating AI report measurable productivity gains. Efficiency compounds. Speed compounds. And when speed compounds, those without intelligence systems fall behind. This is no longer about browsing websites. It is about decision engines embedded into every digital layer. If you want to see how this transformation reshapes. Long before AI became mainstream, pioneers were laying its foundations. In 1950, Alan Turing published Computing Machinery and Intelligence, proposing what is now called the Turing test, according to the journal Mind Archives. He asked a haunting question: can machines think? Decades later, that question no longer sounds philosophical. It sounds practical. Today, AI systems generate language so convincingly that millions interact with them daily without questioning the boundary between human. In 1956, at the Dartmouth Summer Research Project on Artificial Intelligence, scientists like John McCarthy, Marvin Minsky, Claude Shannon, and Herbert Simon formally established AI as a field, according to historical conference records. Herbert Simon later predicted that machines would be capable of doing any work a human could do within decades. At the time, it sounded ambitious. Now, according to automation research reports, machines already perform complex pattern recognition faster than. The breakthrough of backpropagation in neural networks, popularized in the 1980s by researchers like Geoffrey Hinton, David Rumelhart, and Ronald Williams, revived interest in machine learning. According to academic citations indexed in Google Scholar, Hinton's work became foundational to modern deep learning. Decades later, Hinton would be referred to as one of the godfathers of AI. What was once dismissed as academic curiosity became the architecture of today's intelligent systems. In 2012, a deep learning model designed by Geoffrey Hinton and his team won the ImageNet competition by a significant margin, according to published conference results. Image recognition error rates dropped dramatically compared to previous systems. That moment marked a turning point. According to Computer Vision Research Archives, after 2012, deep neural networks became the dominant method across industries. Machines were no longer guessing. They were perceiving. In 2016, DeepMind's AlphaGo defeated world champion Lee Sedol in the ancient game of Go. According to official match records and research papers published in Nature, AlphaGo evaluated millions of board positions and used reinforcement learning to refine its strategy. Go was long considered too complex for brute force computation. Yet the machine adapted, learned, and won. For many experts, this was proof that AI had crossed an invisible threshold. Yoshua Bengio, another pioneer in deep learning, has repeatedly warned about both the power and risks of rapidly advancing AI systems. According to public lectures and academic interviews, Bengio emphasizes that scalable intelligence systems can reshape economies and governance structures. According to economic research institutions, AI-driven productivity growth could significantly impact global GDP. When intelligence scales economically, its influence expands politically. According to the World Economic Forum's Future of Jobs report, millions of roles are expected to shift due to automation and AI integration. While new roles emerge, others transform or decline. The report highlights that analytical thinking and AI literacy are among the fastest-growing skills in demand. This is not speculation. It is labor market data. The workforce is not disappearing. It is being reconfigured. According to research from PwC on global AI impact, artificial intelligence could contribute trillions of dollars to the global economy by the end of this decade. Such projections are based on increased productivity, personalization, and automation efficiencies. When technology influences trillions in economic value, it surpasses being a tool. It becomes infrastructure. The Internet created digital markets. AI optimizes them at machine speed. Search engines once required precise keywords. Now, large language models process intent. According to peer-reviewed transformer model research introduced by scientists including Ashish Vaswani and colleagues in the paper Attention is All You Need, the transformer architecture revolutionized natural language processing. That architecture powers modern generative systems. The Internet indexed information. Transformers interpret relationships between words, context, and meaning itself. As AI systems scale, computational demands surge. According to semiconductor industry reports and research from companies like NVIDIA, demand for high-performance GPUs has grown dramatically in recent years to support AI training. Data centers expand globally to meet processing needs. Electricity consumption for large-scale AI training has become a measurable factor in infrastructure planning, according to energy research analyses. Intelligence now requires industrial-scale power. The Internet once acted as a marketplace of information, but artificial intelligence is becoming the decision engine behind global finance. According to reports from the Bank for International Settlements and Financial Industry Analyses, algorithmic trading now accounts for a significant portion of market transactions in major economies. Machines execute trades in microseconds, responding to patterns invisible to human perception. The Internet transmits financial data. AI interprets it and moves. Credit decisions are increasingly automated. According to research published by financial technology firms and regulatory studies, AI-driven credit scoring models analyze thousands of behavioral variables beyond traditional income and debt ratios. These systems predict default risk using patterns extracted from massive datasets. The Internet stores financial records. AI predicts financial futures. Approval or denial may now be determined by probabilities calculated by unseen systems. Healthcare has entered the algorithmic era. According to peer-reviewed studies published in journals such as Nature Medicine, AI systems have matched or exceeded human specialists in specific diagnostic tasks like medical imaging analysis. Research from institutions including Stanford University shows machine learning models detecting certain conditions with remarkable accuracy. The Internet stores medical knowledge. AI applies it in seconds. Diagnosis begins shifting from doctor intuition. In logistics and supply chains, AI predicts demand fluctuations. According to industry analyses by firms like McKinsey, machine learning models help optimize shipping routes, warehouse management, and inventory forecasting. Billions of dollars in efficiency gains are attributed to predictive analytics. The Internet connects suppliers and buyers. AI determines timing, quantity, and distribution. Economic rhythm increasingly follows algorithmic prediction rather than human scheduling. In warfare and national security, AI is no longer theoretical. According to defense policy research and public military modernization reports, nations are integrating autonomous systems, predictive surveillance algorithms, and AI-assisted intelligence analysis. Strategic decisions are increasingly informed by pattern recognition systems that process satellite imagery and communications data at massive scale. The Internet moves intelligence data. AI extracts strategic conclusions from it. Governments are also experimenting with algorithmic governance tools. According to public policy research and digital governance studies, predictive analytics are used in areas like tax fraud detection and public resource allocation. These systems analyze citizen data to flag anomalies and optimize decisions. The Internet made data accessible. AI makes administrative decisions from it. Bureaucracy slowly becomes computational. Education systems are beginning to integrate AI-driven personalization. According to research from educational technology studies, adaptive learning systems analyze student performance in real time and adjust material accordingly. These platforms claim measurable improvements in engagement and outcomes. The Internet once gave students access to knowledge. AI now determines what each student sees, when they see it, and how they progress. In marketing and consumer behavior, predictive algorithms dominate strategy. According to industry data from advertising research groups, AI models analyze browsing patterns, purchase history, and engagement signals to personalize advertisements at scale. The Internet displays products. AI predicts desires. Influence becomes individualized, calculated, optimized. What appears as choice may be the result of probabilistic targeting. Large language models now process billions of parameters. According to published research papers on transformer-based architectures and scaling laws, performance improves predictably as model size and data scale increase. Studies by AI research labs show that scaling computational resources correlates with emergent capabilities. The Internet expanded horizontally across users. AI expands vertically in intelligence depth. The growth curve is not linear. It compounds. Energy consumption for AI infrastructure is becoming significant. According to energy research institutions and industry sustainability reports, Large-scale data centers require substantial electricity to train and run advanced models. Governments and corporations now plan power grids with AI expansion in mind. Intelligence requires infrastructure. Infrastructure requires power. And power, historically, defines empires. Artificial intelligence is now beginning to redefine what work means. According to McKinsey Global Institute research, 30 to 50% of current tasks in major industries could be automated within the next decade. Jobs will not disappear entirely, but roles and responsibilities will shift to align with AI decision-making. The Internet once allowed humans to coordinate labor. AI now directs the workflow itself. Efficiency replaces human discretion, and patterns dictate value. Even creative professions feel the shift. According to a 2023 report by Adobe and the World Economic Forum, AI-generated designs, music, and textual content are adopted faster than human-created equivalents in corporate environments. While humans still conceptualize, AI accelerates production exponentially. The Internet once displayed human creativity. AI now analyzes, predicts, and replicates creative patterns, challenging assumptions about originality, authorship, and merit. AI literacy is becoming survival skill. According to OECD research, companies increasingly favor employees with AI fluency, including familiarity with data analysis, predictive modeling, and generative AI tools. Workers without these skills risk irrelevance, regardless of traditional experience. The Internet gave information. AI gives capability. Those who cannot interact effectively with intelligent systems will be left behind in decision loops controlled by algorithms. Recruitment is increasingly algorithmic. According to industry hiring surveys, 70% of large organizations rely on automated systems to screen candidates before human intervention. Systems analyze resumes, portfolios, social media footprints, and even inferred personality traits. The Internet once showcased qualifications. AI now interprets signals, ranks candidates, and decides which humans will even be seen by decision makers. Opportunity becomes probabilistic. Healthcare illustrates both promise and peril. According to Nature Medicine publications, AI systems outperform human radiologists in some diagnostics by up to 20% in accuracy. Yet reliance on algorithmic decision-making introduces new risks, including biases encoded in data. The Internet collected knowledge. AI now makes probabilistic medical decisions. Life, health, and human judgment are increasingly influenced by code written in unseen layers. Education and socialization are subtly transformed. According to research from the Brookings Institution, AI-driven personalized learning platforms guide millions of students globally, adjusting content in real time based on behavior. The Internet once allowed anyone to search and learn. AI now determines what each student sees, when they see it, and how mastery is evaluated. Curriculum is no longer neutral, it is optimized by algorithmic objectives. Consumer behavior is tracked, modeled, and predicted at scale. According to research from marketing analytics firms, AI predicts purchasing behavior with accuracy rates exceeding 80% in controlled environments. The Internet once connected buyers and sellers. AI now anticipates desires before they are conscious, shaping economic incentives and personal decisions. Free choice becomes guidance in a network of statistical probabilities. Generative AI expands the speed of knowledge creation. According to research published by OpenAI and MIT Technology Review, modern language models can draft articles, code, and design prototypes in seconds, tasks that once took humans hours or days. The Internet stored knowledge. AI synthesizes, generates, and proposes action. Knowledge ceases to be static, it becomes an active, intelligent layer that anticipates every next step. Infrastructure and power now determine intelligence. According to energy and semiconductor industry reports, scaling AI models requires immense GPU clusters, global cloud networks, and advanced data centers. Electricity, cooling, and networking are no longer background concerns, they define the capabilities of AI systems. The Internet once ran on connectivity. AI runs on computational might. Whoever controls this infrastructure commands unseen influence. AI is no longer riding the wave of the internet, it is becoming the operating layer beneath it, interpreting, predicting, and acting on everything connected. According to McKinsey, PwC, and Stanford AI Index research, organizations using AI outperform peers in efficiency, decision speed, and adaptability. Humanity is now interfacing with systems that think, decide, and optimize in real time. The question is no longer will AI change life? But how will we survive in a world it already governs? By 2030, according to research from PwC and Gartner, AI-driven systems are projected to influence more than 70% of global business decisions. These are not suggestions or tools. They are operational directives. Companies, governments, and institutions are increasingly delegating authority to algorithms capable of analyzing billions of data points in seconds. The internet once gave humans control over information. Identity itself is beginning to exist in digital form. According to academic research on digital traces, AI systems can reconstruct behavioral patterns, predict personal preferences, and even anticipate social interactions. What humans used to share voluntarily online now forms a probabilistic map of personality, skills, and likelihood to act. The internet stored signals. AI interprets them. Our digital shadows may soon weigh more than human resumes, reputations, or credentials. Labor markets are being transformed. According to McKinsey Global Institute, AI adoption could automate up to 30% of work activities globally, but also create new roles requiring entirely different skills. Work is no longer only a measure of output, it is now a measure of how effectively one collaborates with intelligent systems. The internet once connected workers. AI now evaluates, ranks, and optimizes human productivity, turning labor into data-driven performance metrics. Surveillance and decision-making increasingly rely on AI. According to policy studies from Rand Corporation and Brookings Institution, predictive algorithms assist in law enforcement, resource allocation, and policy implementation. Humans may no longer be the final arbiters of decisions. The internet made information visible. AI makes information consequential, analyzing patterns and determining outcomes before humans even notice them. Education, once democratized by the internet, is now personalized through AI. Research from UNESCO and adaptive learning studies shows that millions of students receive individualized curricula designed to maximize outcomes. Performance is tracked, predicted, and guided continuously. Choice is framed. Autonomy is algorithmically informed. The internet offered access. AI offers optimization. Students learn not what they want, but what the system predicts they need to achieve its predefined goals. Even creativity is evolving under AI guidance. According to reports by MIT Technology Review and OpenAI Research, generative AI can produce novels, music, and digital art at scale. Professional artists find themselves collaborating with machines, which generate, evaluate, and suggest. Originality becomes a dialogue with intelligence that is not human. The internet displayed ideas. AI now shapes, accelerates, and filters them for maximum impact. Global infrastructure dictates AI capability. According to NVIDIA and energy sector reports, AI training requires massive GPU farms, terabytes of data storage, and global cloud connectivity. These systems consume enormous electricity and computational resources, making control over infrastructure a source of power. The internet ran on connections. AI runs on computation. Whoever controls processing power now wields influence over the digital and real world alike. AI's influence extends into governance and ethics. According to research from Stanford's Human-Centered AI Institute, AI-assisted decision-making can optimize resource allocation but may encode biases and amplify inequities if unchecked. Governments and corporations increasingly rely on algorithms to guide policy, enforce regulations, and monitor compliance. The internet once gave humans tools. AI now shapes outcomes, silently making millions of micro-decisions that collectively define societal. The fusion of AI and the internet creates a system where every action, interaction, and choice can be influenced or predicted. According to studies from MIT, Stanford, and global consulting firms, advanced models now forecast consumer behavior, market fluctuations, and even social trends. Humans can still act, but increasingly, the environment they operate in is pre-calculated, optimized, and subtly directed by intelligence systems far faster than human comprehension. We stand at a moment in history where AI is becoming bigger than the internet, controlling decisions, shaping economies, and influencing identity. According to McKinsey, PwC, Stanford AI Index, and multiple peer-reviewed studies, this transformation is already underway, not in the future. The internet connected us. AI now interprets, predicts, and optimizes. To survive, adapt, and understand the coming world, subscribe now, because the story of human relevance in the age of AI is only beginning.